So good evening everybody. I am Jay Sri. I am going to take sequential logic circuits parallel in parallel of shift registers under analog and digital integrator circuits. Okay. This is what parallel in parallel of shift registers. The parallel in parallel of shift register is a type of shift register that allows data to be loaded in parallel and also retrieved in parallel. So unlike shift registers, PAPO shift register don't shift bits. Instead, they store and output the data directly. This is what parallel in parallel shift registers. Okay. Next one. In this mode, the 4-bit binary input B0, B1, B2, B3 is applied to the data inputs D0, D1, D2 respectively of the 4 flip-flops. Okay. As soon as the negative clock edge is applied, the input binary bits will be loaded into the flip-flop simultaneously. The loaded bits will appear simultaneously to the output side. Only clock pulse is essential to load all the bits. Next one, this is the operation of PAPO shift register. There are three main operations of PAPO shift register. Number 1 is what? Data loading. Number 2, data storage. Number 3, data output. So number 1, data loading. Data is loaded simultaneously into each flip-flop of the shift register through the individual parallel input lines. When a load control signal is activated, the input data is latched into the shift register. Next one, data storage. The loaded data remains stored in the shift register until a new load command is given. It holds the data and makes it available for parallel output. Third one is what? Data output. All stored bits are simultaneously available at the output and data can be read at any time via parallel output pins. So these are the block diagram of parallel in parallel shift register. Here at the top end the parallel input is given, at the bottom end we are taking the outputs with the 4 flip-flops. Right, with the 4 flip-flops we can take this output. Next one, let us see the applications of parallel in parallel shift register. So it reduces time, the maximum efficiency. It reduces the time and increase the efficiency. That is what the purpose of parallel in parallel shift register. Okay, so temporary data registers, microprocessor data registers, data buffering, parallel data transfer, digital counters, data synchronization and data sampling and latching. These are the main applications of PAPO. So let us see one by one in detail for these applications of PAPO. Okay, so temporary data storage device in digital system, CPU and microprocessor system. It can store intermediate data used during arithmetic and logic operations. It is used in the register file of RISC and CISC architectures. Okay. Next one, microprocessor data registers. It is used as a general purpose data register within CPU to store and transfer binary data. It helps store operands, intermediate results and final results during calculations. Okay. Next one, data buffering. It is used as a buffer to temporarily storage multiple bits of data before further processing. It is commonly used in memory devices, digital signal processing and image processing. Next one, parallel data transfer. It is used to transfer multiple bits of data from one system or module to another system simultaneously. These are the main applications of PAPO. Next one, digital counters. Okay, in this counters it acts as a register in digital counters to store and display the count values, often found in frequency counters, digital clocks and event counters. Next one is what? Data synchronization. It helps to synchronize the data between the different clock domains, ensuring data consistency in systems where clock frequencies differ. It is used in FPGA and ASIC design for synchronization across different modules. Next one, data sampling and latching. It is used to sample and latch input data for analysis or further processing. It is essential in analog to digital converter systems and logic analysis. Okay. These are the applications of PIPO shift registers.